Well, I was leaving anyway because I had a dentist appointment, but I'm not even going to the dentist appointment now. But I'm sick. I went to the doctor yesterday thinking that maybe I had strep throat, hoping I had strep throat, that they could just give me medicine and send me home, but no strep.
What is it?
A flu-like virus, that's what she said.
Okay.
So.
She had some Ebola.
Maybe Ebola, but
Did you hear that the flu vaccination this year, like, only, like, prevents you from getting, like, 40% all the time? So don't even get it because it's
that's how the flu vaccine is every year. The issue this year is the flu that people are getting. It wasn't in the flu vaccine, but they can't. The thing with viruses is that they mutate, and so they can only, they make the vaccine ahead of time, and it happens every year. But this year they're saying that the main type of flu that people are getting is not what's in the vaccine, so it is true. But I'm just trying to keep my distance. I have my scarf here so that I can cough in, and I didn't grade your papers. We're not gonna touch any papers that I touch, so we're gonna just try to,
On Saturday.
so, what? Perfect. Does anybody have homework questions? Did anybody do their homework?
We say no, you're not giving us a homework quiz.
Tomorrow is the last section, which is called proof by induction, probably the section that's going to be the most difficult, so just be prepared for that. Today I just need to finish up 9.5 day 2, a couple more formulas. Wednesday we'll review, Thursday we'll have a test, Friday we'll start reviewing for the final, because next Wednesday is your final exam, children.
School's almost halfway over.
And then I
Reading number 2. I love all the time.
Part 2. The big thing is, guys, when we have the test on Thursday, I'm going to let you write out a formula sheet. I'll talk about it on Wednesday with you, what you can write out. Basically, you can write formulas only. You can't work any problems out. You can't write notes. You can't, it's just formulas only, what the letters represent. But what you have to know is which formula to use at which time on those problems, because I don't care that you have them memorized, but I just care that you know when to use them. And on number 2, it just says write each sum using summation notation, assuming that the suggestion pattern continues. And so that was our lovely little sigma. Oh, it's still no better here. I'm going to say n equals 1, and then notice that we're adding 3 each time. And so I can see right away that it's an arithmetic sequence. And so if I'm trying to write the formula for an arithmetic sequence, I'm going to go back to 9.4's notes and get that formula for the explicit term in an arithmetic sequence, which was the first term plus n minus 1 times the common difference. And that's going to be what I write here. So I'm going to say 2 plus n minus 1 times 3. Or that's going to be 3n minus 1. And then the other thing that you have to use, put in when you're doing sigma notation is the top number. You have to figure out what term, like how many times did they add 3 to get to 29. You could just work it out. You also could just set this number equal to this formula, and you'll get what n is on that one. And it does turn out that n is 10, so that's why I put 10 up there.
Yeah, so it's going to get mad at you.
it's in
Yeah,
the
that
notes.
wasn't very nice.
No, it's in
Yeah, that wasn't very nice. Are you seriously done, Katrina?
Well, it's in the notes. The exact same one.
Okay, then I didn't get 16 over there. Well, I tried to type it in, it didn't work. Okay, it is negative.
Do 16, please.
No.
16, please.
Alright, that was great. Yeah. Thank you, I promise you.
a negative 1/6 instead of a positive 1/6 on 16. Probably on 16, if you didn't get it to work out, it's because of the whole, like, you crossed out your negatives, right? Like, it's supposed to be like 1 minus r to the nth power, which I think would be 10 on this. Is that true?
Yeah.
You cannot just make these negatives go away. That's what tends to happen, is you guys see minus a negative and you think, oh, I can make that a positive, but you have to do exponents first, and so this is positive when you take it to the 10th power, so it's still going to be minus there. So I would say check that again. We'll see about this one in a second. 19, you have to figure out whether it's arithmetic or geometric, and I think we are multiplying by negative 1/2 every time. So this 19 is kind of like 16. And so you need to find the sum of a geometric sequence is the first term times 1 minus r to the n over 1 minus r. So that would be 1 minus negative 1/2. It is 12 all over 1 minus negative 1/2. And on the bottom, you can make that turn into plus because there's no exponent there. And this is where you just have to be really careful typing things in using parentheses correctly. Do it a step at a time if you want. Like on the top, you could just do first on your calculator 1 minus parenthesis negative 1/2 to the 12th power. Like you could do that first. You need a parenthesis there, I guess, if you do it that way. 1 minus parenthesis negative 1/2. It's an awesome voice I have going. To the 12th power. Then I can multiply that by 4. And then I can divide that by 1 plus 1/2. If you're going to type that in your calculator as 1 plus 1/2, you have to put parentheses around it. Otherwise, you could just say 1 plus 1/2 is 3/2 and divide by that. And I got 2.666015625, or in the book they just said about 2.666. My advice on the test is make sure you show me the formula, like type it out, like write out that and then type it in your calculator. So in case you type something in wrong on your calculator, at least I can see you have the right formula and the numbers in the right spot. Okay?
What's that?
This was a different problem over here. I didn't print your notes out today.
I think it would be really bittersweet.
It's bitter. They're pretty short today, though.
It's 1.5.
There's not a homework quiz. There should be a homework quiz every Monday because you guys are slackers and think you don't need to do homework on the weekend.
We were getting our Christmas tree at 6:30 yesterday. It's dark. Maybe it's our children's class. That's fine.
Hope it's a good one. So on Friday, we talked about a finite series. Finite meaning that it stops after so many terms. Well, there's another type of series called an infinite series. And the big difference is that an infinite series goes on forever. And so instead of having like a number up there like 5 or 7 or 10, it has an infinity sign, which means that it goes on forever. It never stops. You haven't written notes in so long you forget what it's like to do it. I printed your notes out for tomorrow. I already did it.
Actually, can I be here tomorrow?
Plan on it. They didn't even test me for the flu. She just listened. She just said a flu-like virus. It just means a virus, right? She tested me for strep, and then she listened to my chest, and then she said, you have a nice cough going there. You probably have one of those flu-like viruses that are going around.
Probably.
Get some rest, drink lots of fluids. If you still have a temperature tomorrow, you probably shouldn't go to school. But I didn't listen very well. And I'm drinking Powerade and water. Well, no, Powerade and ice. But then I have a cup of water also. And I took my Dayquil this morning. I got my Advil ready to piggyback on it in just a minute. Just keep the fever down. I'm good to go. I have Hall's cough drops too. Pretty rough. Mrs. Hodge gave me this big pamphlet about the difference between cold and flu and all my symptoms. It's ECA this week, and we have a test this week. I can't miss school. It's like the worst time to be sick. I cannot miss proof by induction tomorrow. Like, there's no way I can miss this day. So, I'll be here. Unless my kid gets sick, and then I won't be here. So, that's why I have to come to school when I'm sick. So that when my kid gets sick, I can stay home. Because infinite series go on forever, they have something called a partial sum, and I think it's just silly because it really just means add up that many terms. So when it says find the fifth partial sum of this sequence, it doesn't mean add up to infinity. It just means add up the first 5 terms. So don't be thrown off by that. There's some of those on your homework today. It's exactly what you should have done on your homework on Friday if you did your homework on Friday. If I'm going to find the fifth partial sum, I'm just going to start at 1 and go to 5. So I'm just going to take 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. If it said find the 10th partial sum, I would add up the first 10 terms. And I think that adds up to 55. 9 plus 16 is 25. 25 and 25 is 5. Questions about that? That's not so bad, right? But what if I want you to add up something that goes to infinity? It seems impossible, right? What if I said find the sum from 1 to infinity of 1/10 to the nth power? Let's write it down, and then we're just going to work out some terms here and see if I can teach you a little pattern here. That's kind of cool.
When you say kind of cool, you're listening because you're just thinking about it, or just actually?
I think it's cool. Who knew you could add up something that goes to infinity? And it actually equals the sum, like a finite thing, it actually equals something. That's cool. It does, I'm going to show you. What would I get if I plugged 1 in there into that sequence? 1/10. What about if I plugged 2 in there? 1/10 to the second power would be 1/100. Just taking powers of 10, but they're on the bottom, right? So if I plug 3 in there for n right here, I would get 1/10 to the third power, which would be 1/1000. You follow me on this? I'm going to go one more. Next one will be to the fourth power, which would be 1/10,000. And then I'm just going to put plus ... because it goes on forever. So I know I'm very anti-decimal most of the time, but let's do decimals on this. 1/10 as a decimal is just 0.1, right? 1/100 is 0.01. Plus 1/1000 is 0.001. Plus 1/10,000 is 0.0001. And every time I do the next term, do you agree it's going to give me another 1? So although I'm not going to actually make this go to infinity, can I say I know what the sum is? 0.1 repeating?
Could be 1.1 times 10 to the 6th power.
Do you know what 0.1 repeating is as a fraction?
Huh?
Do you know what 0.1 repeating is as a fraction? 1/9. All the ninths are just the top number repeating, like 2/9 is 0.2 repeating. 7/9 is 0.7 repeating. So we can say this goes to infinity, it goes on forever, and we can say it adds up to 1/9. You seem very unimpressed, but we just added something up and went to infinity. And it equals 1/9. Now, obviously, every time I'm not going to make you do the pattern here. There's a formula of how you can add up an infinite series. No, I mean like a formula with like the S and the R, like we just did on the last problem, like on the last day stuff. I forgot you didn't do your homework. But there we go. I'm going to give you a. Remember when we talked about converging and diverging? It's important that the only type of series that is going to have a sum when it goes to infinity is one that converges. If it diverges, then it won't have a sum. So there's only certain sequences that you can add up to infinity. And so if the sum of an infinite series converges, then it will approach some specific value, like 1/9. But if it diverges, then there is no sum, and I'm going to show you a really quick way to know whether it converges or diverges. And then I have a little formula here for you. And so again, I've been giving you lots of formulas for this chapter. I bought a new thing of hand sanitizer there. Right. I know, look, right there. If you have a sum that goes to infinity, and again, notice that this is a geometric series. An arithmetic series is never going to have a sum, a finite sum. Infinite one. The rule is that whatever your R value is, the absolute value of it needs to be less than 1, which means it needs to be a fraction between 0 and 1, basically, because that means that it's getting smaller over time. And so some of these problems will not have a sum, and so you can just say it diverges and you don't have to do anything. But if R is less than 1, then the sum is just less complicated than the formula that I gave you last week. It's just A, which is the first term, divided by 1 minus R, which is your common ratio. And again, you don't have to memorize this formula, you just have to know how to use it. The common ratio, like what you're multiplying by each time. Or it's just R in this case. But like in the last one, it would have been 1/10. Like R would have been 1/10. On number 19, it was 1/2. Or negative 1/2. The sum, like the sum of the we should say infinity or something, huh? Questions about that? Anybody still writing that down? So stressed about our time that we have left in here.
It's Christmas time, I can't be stressed.
And I have the flu. Flu-like. That's what I like to say. It's flu-like. It sounds good. It is. Alright, I'm going. Everybody's good? So, most of your homework today is this. Determine if the infinite geometric series converges. If so, find the sum. So the first thing you need to do is figure out what R is. And if R is between 0 and 1, then you can use the formula. If R is bigger than 1, you cannot do the formula. So what about that first one there? 1 over 48 plus 1 over 16 plus 3 over 16 plus 9 over 16. Maybe those numbers are getting bigger. Yes. What are they multiplying by each time? Do you know? 3. You multiply by 3, 3 goes into 48, I think, 16 times. You multiply by 3 again, you get 3 over 16. You multiply by 3 again, 3 times 3 is 9 over 16. If r is bigger than 1, then it diverges. So, if so, find the sum. I'm just going to put diverges, or you probably are just going to put no. There's no sum because it's just getting bigger. That means it's just going to go to infinity. Can't be a sum. So sometimes they're going to give it to you like that in the pattern, and sometimes they're going to give it to you like this in the notation. I like the notation because I can see right here that this is my r value, right? If you think about the formula that we've used, so like r to the n minus 1. If you aren't sure that that's r, you could always work out a few problems. And I did this one on purpose because look, they kind of switched it up on us. Normally we say n equals 1, and then it says n minus 1 up here, but notice they changed it. They made n equals 0. So then it's just n up here, and it's the same thing, it's just a different way of writing it. But just be careful on that when you're doing your terms on that. But on this one, since r equals 1/2, this is going to converge. That's a C, not an O. So I can just do a over 1 minus r. I think that's my formula. A is what you get when you have the first term. What is the first term of this problem? The first term would be what I get when I plug this into this problem.
So it's what? 16.
1/2 to the 0 is 1. 16 times 1 is 16. And then r is 1/2, which means you get 16 over 1/2, not 1/6. And 16 divided by 1/2 is really just 16 times 2, which means that this sum is 32. That's going to be really loud. Sorry. Questions about that? This formula is way better than the ones from Friday. I mean, that's all my notes. Which means use your time wisely. If you didn't do Friday's homework, do that too. 5, 6, 24 through 27, 29, 30, and 46.